Welcome, everyone. This is Professor Richard Holowczak, and this is the Entity Relationship Modeling Lecture Part 3. If you've been following along with the lecture series, you've reviewed the database development lifecycle many times before, where we identify an organizational problem or opportunity, we gather requirements by interviewing users and collecting documentation, and then we create a conceptual data model called the Entity Relationship Model. In the prior Part 1 and Part 2 of this series, we discussed the 4 components of the entity relationship model, including entities, attributes, identifiers, and relationships. In Part 2, we spent a lot of time talking about the degree and cardinality of relationships. For this Part 3 of the series, we're going to talk about some additional modeling techniques that can help enhance your ER models and your diagrams. First topic I want to discuss is remodeling multivalued attributes. Imagine that we get the following information from our users. We need to keep track of our employer's address, contact information, and skills. It makes sense. If you have an employee, you want to know how to contact them, you want to know where they live, so you can send them a paycheck, and you'd like to know what their skills are. Maybe as a first draft, you might model it like the entity on the left. We have the name of the entity, a nice identifier called employee ID, and then an attribute called address, another attribute called contact information, and another attribute called skills. In my mind, this is exactly what was given in the case study here, and it's pretty much just copied word for word. There's a few issues with this. First, address actually contains several pieces of information, including the street, apartment number, city, state, and zip code. Rather than try and cram all of that into one attribute called address, we'd prefer to have it spread out with street, apartment number, city, state, and zip code attributes. In a similar way, the contact information also can be extended, maybe phone number, phone extension, email address, perhaps some other attributes. The idea here is to not try and cram a bunch of data into one or two attributes. Instead, use as many attributes as is necessary to capture all of the data. This will help keep data organized. It will also make it easy to sort and search on the data later on when we actually create the database. The last issue comes down to skills. And skills is not something that is a fixed quantity. You may have employees that know how to write software in Java and Python and C++. Another employee might have skills in accounting or payroll. Another employee might have skills in management. Rather than try and cram all of those different potential skills into one attribute, we can model it as a separate entity. We can have a skill ID and a skill description. So now, with this many-to-many relationship, we can connect an employee with many different skills. So one employee may be prepared with many skills, and one skill may be learned by or acquired by many employees. We could have a skill called Python programming, and many of your employees have that skill. We could have a skill called Java programming, and perhaps none of your employees have that skill. That's okay. It's okay for the model. We could have an employee that has 5 different skills. That's certainly fine. We could have an employee with no skills, and that also will fit in the model. So what we're trying to do here is make the model as general as possible so that we can accommodate all different combinations of employees and skills. Now it's your turn. Can you think of a way we can expand on this model to provide even more details about the skills an employee has? Think about some of the work that we did in Part 2, where we looked at many-to-many relationships, maybe between vendor and product, and see if you can apply what you learned in Part 2 to this situation. I invite you to pause the video and We'll take a look in a few minutes at what one potential solution might be. Okay, here's one example of a way to expand our employee skills relationship. If you remember from our lecture video part 2 on ER modeling, we talked about how any many-to-many relationship can be recreated as two one-to-many relationships. Some of the things that we'd like to know about an employee with their skills might include the skill level. Are they a beginner? Are they intermediate? Are they an expert? Are they a guru or a master of a skill? How many years of experience do they have with that skill? And do they hold a certification with that skill? For example, an employee might be a beginner at Java programming, but they might be an expert at Python programming. They might have 5 years of experience with Python programming and maybe even hold a Python programming certification. All of these things can be now captured by this model. And again, we can play around with the verb phrases here, but it roughly reads, one employee may be achieving many skill levels, and one skill level must be learned by one employee. From the other side, one skill may be specified by many skill levels, and one skill level must be a level of one and only one skill. Hopefully you can appreciate that the introduction of the skill levels entity provides a tremendous amount of flexibility in specifying the exact skills that an employee has. The next topic I'd like to talk about are derived attributes. Very often, we will have a model where from a one-to-many relationship, there seems to be a need to count or keep track of how many instances are matched up. For example, we have vendors who may be receiving many purchase orders. This is an example that we gave in the part 2 of our lecture series. And it's very common for students to put an attribute like the number of purchase orders. So we have vendors, we have the relationship, and we're including here the number of purchase orders that the vendor has received. Attributes like this are really not necessary because we can derive this value by counting the instances of purchase orders. Later on in the semester, when we talk about structured query language, we'll see how to do this very, very easily with a simple query. So there's no need to include an attribute that we can derive in the model. Another example we have is we might want to keep track of the years an employee has been at the company. We might include an attribute like years employed. The problem with an attribute like years employed is that every year we have to update it to add another year. Instead, we can use an attribute called date hired. And then when someone asks the question, how long has this employee been with the company? We can easily calculate how long they've been employed by taking today's date and subtracting the date hired. That's how we can figure out years employed. So years employed can be derived, but we're going to need an attribute like date hired in order to make that calculation in the future. Now I'd like to turn our attention back to identifiers. And this gets into a little bit of a very esoteric situation that happens very, very seldomly in our modeling. But it's important to bring it up because we need to make sure that we can address it if it does come up. Almost all of the entities that you will have in a model are going to have a single attribute for an identifier. And we talked about this in part 1 of the series. Anytime you have an entity, all you have to do is take the name of that entity and put ID next to it, and you get an artificial identifier that just simply works. It's no big deal. to have customer ID, product ID, vendor ID, student ID, review ID, message ID, doctor ID, patient ID, you name it. It's a very, very simple way. However, there's two situations that might come up. Occasionally, we'll have an entity with no identifiers whatsoever. And the second situation is we may have an entity that has an identifier, but that identifier is not sufficient to uniquely identify an instance of the entity. And these are a little bit tricky, a little bit subtle, but let's go through them. First off, sometimes we have entities that have no identifiers. And we saw this with the vendor products example. We also just saw this at the beginning of this video when we talked about the employee skills model that we added to. Here, characteristics doesn't really need its own identifier. I suppose you could put characteristic ID if you really wanted to, but it's actually not necessary. Whenever we have one of these intersection or associative entities, we need to indicate to the developers, the software developers, that this entity is special in some way. And we do that by placing a double box around the entity. You've seen this several times before, and I haven't really mentioned it, but now I'm mentioning it. The double box essentially is an indicator that, hey, when you deal with this entity called characteristics, you're going to need to borrow the identifier from vendor and the identifier from product ID. We don't have to put those identifiers in here right now, but in the next step in our development process, where we convert this ER model to a set of relations, it's going to be important that we know we have to borrow vendor ID and product ID. So that's the main reason why we put this in a double box. Later on, we'll combine vendor ID and product ID, and those will be together with characteristics in the database. We don't need to do it now, we just need to put the double box around so that the database developers will understand what to do in the next step. The next situation is very, very, very specific, and it only happens really just a handful of times. However, the model that it shows up in is very common. And so I feel compelled to really try and do my best to explain this situation. And here, we're going to call this an ID-dependent entity. And what's going on here? We have a very typical model where customers may be placing many orders. An order is going to be made up of many order items, and products might be ordered on many of those order items. This is such a common model. You saw this already with the vendor purchase order model, and here we see it with the customers placing orders. Any type of retail business, really almost any business where a customer buys something from you, is going to have this model. If your company sells services instead of products, you would just replace the products entity with services. So again, you'll see this if you do any type of modeling for any type of business, chances are you'll see this type of model in place. Now, why do we model orders and order items separately? Let's take a look at a couple of examples. If you have ever gone to a coffee shop or a grocery store or really any type of retail establishment, you've been presented with a receipt. Here I have a receipt from a Thai food restaurant, and receipts are usually broken up into two pieces. You have some information at the top that is in common for the entire order. And sometimes we would call that an order header. You have the name and contact of the restaurant, you have who the server is, what station they're at, the order number, you can see that here, whether it was for delivery, it looks like it was for delivery, and where that delivery was going to. So you have all of this information at the top that is common for the entire order. And then somewhere in the middle, you have a list of order items. This particular order has 1, 2, 3, 4, 5 order items. I'm not sure why they're ordering cheese pizza or pepperoni pizza from a Thai restaurant, but here we are. You've got all of these items ordered from this restaurant. So there can be many items on a particular order. And this is the main reason why we split up the order header information from the order items when we model. So going back to our ER model, we can see here that we've split this up into orders and order items. Orders are the attributes that are common to the entire order, like the date, required delivery date, payment terms, and order status. And the order items are the variable number of items, including the quantity ordered, quantity delivered, item price, and item discount. One order may be made up of many order items. One order item must be an item ordered on one and only one order. So we have this one-to-many relationship between orders and order items. And again, that just follows the way most businesses work. It really doesn't matter what the business is. You'll have header information that's common to the whole order, and you'll have a series of items. In order items, we have an identifier called item number. And as you can see in this example, we might number them item 1, 2, 3, 4, 5. Over here's another order. It's got item 1, 2, 3, and 4. The question comes, is the item number by itself enough to uniquely identify an order item? And the answer is no, it is not. If I just told you, hey, let's look at item 3, you would have no idea which order I'm talking about. In other words, order items is dependent upon the order's entity in order to figure out which item we're talking about. You need a combination of the order ID and the item number to uniquely identify the order item. If we look at our example again, we would need a combination of order 21, item 3. Now we know exactly what item we're talking about. Over here, it's order number 4572, and maybe we'd look at item 4 to know exactly which item we're talking about. We call this situation ID dependence. Order items is ID dependent upon the order's entity. And that's why we have a double box around order items. Again, this is a very rare situation, but it is one that comes up whenever we talk about this retail sales case where we have customers' orders and order items. So it's important that we understand why the double box is here and the fact that item number by itself needs to be eventually combined with order ID to uniquely identify an instance of order items. This is just summarizing the discussion. ID-dependent entities contain an identifier, but one that is insufficient to uniquely identify an instance. It requires the identifier from another entity to combine together. We indicate it with a double box, and in this example, as I just mentioned, order ID and item number together will eventually allow us to determine exactly one order item. The next topic I want to talk about are relationships that have degree 3 or degree 1. All of the relationships that we have discussed so far have had degree 2, meaning 2 entities involved in the relationship. And now I want to talk about a couple of other variations. So here's a common example. We have customers who are placing some orders and they're being helped out by a salesperson. This is very typical. Customer being helped by a salesperson to place an order. We call this relationship a ternary relationship, a relationship of degree 3, meaning that there are 3 entities involved in the relationship. The problem that I have with a ternary relationship is that it is ambiguous. And what do I mean by that? I can think of at least 2 different ways that we could interpret this model. The first is what I would call the sales territory model. In a sales territory model, salespersons are assigned to customers. For example, you may be the Northeast salesperson for a pharmaceutical company. That means that any of your customers who happen to have offices in the Northeast of the United States, they're automatically assigned to you as their salesperson. So now it doesn't matter how many orders are placed. All of those orders are associated with the same salesperson because the affinity or the connection is first between salesperson to customer and then customer to place the order. So for example, if we want to calculate the salesperson's commission, all we have to do is sum up the orders for the customers in that region, and then we can immediately see what that salesperson's commission ought to be. So this is a very specific sales territory model. Another model that probably all of us are familiar with is a retail sales model. And in this model, when a customer comes into a store, they go ahead and they place their order, and maybe there's a salesperson that happens to be there that helps them out. If the customer leaves the store and comes back an hour later, it could potentially be a different salesperson that helps them out. In other words, the customer places the order with the help of whatever salesperson happens to be free at that time. So every single order a customer places could be potentially with a different salesperson. You can see how that is different than the sales territory model, where it doesn't matter where or when the customer places the order, they are always associated with the same salesperson. Here, the salesperson changes for every order. So going back, the reason why I don't like a ternary relationship is because it's ambiguous. We don't know whether this is representing the sales territory model or whether it's representing the retail sales model. So my suggestion is, if you see a ternary relationship, go back to the users and interview them again and ask them about the nature of this relationship. And ask them whether this is a sales territory model or whether it's a retail sales model or whatever the modeling situation is for the case you're working on. The bottom line is, try not to use ternary relationships. In fact, I would suggest don't use them at all. Find a way out of it. Maybe even if you have to introduce a new entity to represent the relationship, but don't use ternary relationships at all. All right, you've seen this human resources example many, many times now. There's one sentence in here that I have been ignoring or skipping over for a very long time. And that is, each employee reports to a supervisor. I've read that sentence and I've set it aside for part 1 and part 2 of this series, and now it's time to deal with this. Every employee reports to a supervisor. Well, you might think maybe we can model this with a new supervisor's entity. I think people highlighted or might have highlighted supervisor as a potential entity early on. But let's take a look at this. The relationship seems to make sense. One employee must be supervised by one and only one supervisor. And one supervisor may be supervising or managing many employees. This seems to make perfect sense to me. But what is it that you notice about the attributes of supervisors and employees? Take a look at the attributes. They both have a first and last name, a street address, apartment, city, state, zip code, phone number, and email address. In other words, they are pretty much identical. And why is that? This is the case because supervisors are also employees of the company. They also work for a department. And they also turn in timesheets, and they also get paychecks. Supervisors are employees. Some employees are actually supervisors. So there's really no difference in the entity. They're really talking about the same people. The only difference is the job role. The work that they do is slightly different. So instead of maintaining a separate entity for supervisors, we can reuse the employee entity and introduce what's called a unary relationship, a relationship of degree 1. Here, we're going to have an employee that may be supervising many other employees. Sounds really weird, but let's fill in the verb phrases and see how this goes. One employee may be supervising many other employees, I guess, and one employee may be supervised by one and only one employee. Why do we have the maybe here? Because eventually there has to be an employee that has no supervisor. Maybe that's the CEO, or maybe that's the president of the company. There's nobody higher in the chain. This type of relationship, as I mentioned, is called a unary relationship, meaning it is of a degree 1. There's only one entity involved in this supervisor relationship. And this actually comes in pretty handy. The other thing that we've added is job role, okay? And so now we can have the supervisor indicated here by their job role. And that way we could separate employees from supervisors if for some reason we want to run a report or we want to run a query just looking at employees or just looking at supervisors, or we could ignore job role if we want to look at all of the employees. This also conveniently allows us to promote an employee to a supervisor role simply by changing the job role. And of course, we could also demote someone, take away their supervisor role, by just putting them back to a regular employee role. Very, very handy, pretty sophisticated. This doesn't come up all the time, but it's a very nice way of economizing on the model and really making it efficient and keeping us from having to maintain two sets of data. All right, now it's your turn. There's another situation where this might come up, and that's called the student-tutor relationship. So read through this paragraph and then sketch out a model that you think might work to cover this situation. Students who need help studying for this class can work with a tutor who will give them study tips. Students who have completed the class last year can work as tutors to help other students study. So you see the word students a lot. Sometimes they're students who need help. Sometimes they're students who are willing to help others. How do you think we could model this in an efficient way? I invite you again to pause the video and do a sketch, and then we'll take a look at a potential solution when we come back. Okay, here we are. Our unary relationship makes another appearance. We have our students with all of their contact information, like we would typically find. And then we're going to use this unary relationship. One student may be tutoring many other students. You don't have to be a tutor, but if you want to, you can work with many other students. And going the other direction, one student who needs help may be tutored by one other student. So if you need help, you can really just go to one other tutor to help you out. You don't have to go for help. That's why the first minimum cardinality here is a 0. If you do want help, at most you can work with one other student. Of course, we could probably expand this further, and I'm not going to show you an example of it, but just imagine that we wanted to expand this to include something like the subject that is going to be tutored. And then we could expand this model further and say, not only can a student work with one tutor, but they could work with many tutors. You could work with many tutors over many different subjects. So there's a really ripe area that can be explored to expand out this model. But this is just, again, one other example of a unary relationship, a relationship of degree 1. Okay, that's all we have for this video for part 3. I don't know yet if there's going to be a part 4. If there is, you'll see it. Otherwise, we're going to continue on with the next phase of our development process, which is to convert ER models to relational models. And you will find those notes and videos on my website, holowczak.com/dbnotes. Thanks for watching, and I'll see you in the next video.